Dear friends, for which of you which are not familiar with the pressurization unit, today I will try to explain in a simple way how a pressurization unit works. Now if you will see in this picture, the pressurization unit, it is not very complicated. It is got a floating valve which allows the water to fill the tank, the pumps which push water into the installation, the one-way valve which is not allowing the water from the installation to go back into the water tank, and also you have the pressure probe which monitoring the pressure into the system. The pressurization unit is also fitted with a printed circuit board and an electronic display. I'm talking about the new ones. So this printed circuit board have a software done by the manufacturer which will act against a specific pressure and also will register and take action if the pressure will go over and under the maximum or minimum set point by you. So I will explain step by step how this pressurization unit works. Now let's see how the pressurization unit it is connected into the system. We all know that pressurization unit it is connected to the main cold water supply. And what you will see in this picture, there is a valve painted in yellow. Why it is in yellow? Yellow represents an open valve. That's my choice. So everything you'll see in yellow, it should be active, with the exception of the pressure probe into the pressurization unit and one-way valve, because they're active by default. Anytime I will energize the pressurization unit, they will be active by default. So I turn on the main cold water valve because I want the water to reach the pressurization unit valve and the filling bypass valve. Looking into this picture, now you see, which is colored in blue, the water reached the pressurization unit valve and the filling bypass valve. The next step it is to open the pressurization unit valve, which is not yet energized. Once you do this, the water tank will start to fill up. The floating valve of the pressurization unit will allow the water to fill the tank, and when the tank will be filled, then will turn off the water, as you will see in the following pictures. Slowly the tank fills up and the floating valve progressively will reduce the water flow that allows the water to fill the tank. Looking to this image, you will see that the tank it is almost full. So now the floating valve will stop the water to go into the tank. Now the tank is full and the floating valve stop the water to go into the tank. I just want to make a little comment here. As you'll see on the right hand side of the pressurization unit, kind of in the middle, I have a pipe. This is an overflow. So if I have a leak onto the floating valve and the water will not be 100% stopped, that overflow will be directed outside the building, not to flood the premises. Another feature which is very important would be the pressure relief valve. Pressure relief valve, it is meant to protect the system against high pressure. If under any reason there's a malfunction into the system which allow the pressure to grow above the maximum allowed set point, the pressure relief valve will allow the water to go out of the system to protect the system and also to protect you. I know that the pressure vessel it is preset by the manufacturer, but I always like to check and I always like to make sure that my pressure vessel have the right pressure. So in my case, let's say that my installation requires that the pressure vessel will be pressurized to 1 bar. Now if everything it is okay, I'm very tempted to turn on the pressurization unit and to use its filling function, like first filling, but I don't want to kill the pumps, and I decided to use the filling bypass until I reached not the right pressure, but I'm going as close as I can. So I'm using the main cold water supply pressure, and I'm just watching the gauge, this manometer that you'll see on the right hand side on the top. So first I open that valve which allows the water to go into the filling bypass, and now I'm preparing to open the second valve to allow the water to go into the installation. I open the second valve of the filling bypass, and as you will see now, the water goes into the installation. It is a blue color, so you have water going via the heating circuit, the pressurization vessel filled with water. And can't you see in the picture where the pressure release valve, the water is stopped, because that will only allow the water to pass by if the pressure will over exceed the pressure set by you when you design your system. In my case, in this case, it is 3.5 bars. The pressure reached almost 1 bar, kind of 0.7, 0.8 bars. And after I will consider that the system has been filled up with water, I'm going to take another action and to turn off the bypass filling valves, and I will redirect this function, and I will allow the pressurization unit to monitor the pressure into the system and to complete the rest of the necessary quantity of water. Looking into this picture, you will see that both valves of the filling bypass are closed. As I just said, I opened the valve, the pressurization unit valve, and now I'm preparing myself to energize the pressurization unit and to set the alarm and the running pressure. There are many types of pressurization units, and this specific one, let's say you'll turn it on, you'll have the greeting, and then you have to set up the system. And what does it mean to set up the system? You will set up the higher limit and the lower limits, which will be an alarm that will stop the system if it is correctly integrated. Also, you will set up the point where the pressurization unit will start to fill the system with water, and there's some other function, but as I said before, I have some more videos which are talking about this. Let's say this is a case where my system will start charging the installation with water if the pressure will go as low as 5 bar. This is the set point. So if the pressure will go slightly lower, like or at 5 bar, the pumps will start to fill the installation with water, and when the pressure will reach 0.8 bar, this will be the set point. The pumps will stop. Please do not confuse this stop with an alarm stop. This is the running point. So this is the pressure which the pumps will fill the installation with. Now, as I told you before, we have to set up the lower limit. In my case, if you'll have a lower limit of 0.4 bars, the system will stop, and the pressurization unit will have a sound alarm, and also you'll be capable to read visual on a display. But as I said before, be careful, some units are very old and you do not have this function. However, you can use what you learn in this video to do an assessment yourself. You have a high alarm. To be very careful when you set it up, the higher alarm of the pressurization unit should be below the pressure relief valve set point. Otherwise, you might have the bad surprise to set up that pressure above the pressure release valve. I mean, the pressurization unit will have the pressure set up above the pressure relief valve. In that case, if the pressure will grow too much, the pressure relief valve will allow the water to go out of the system, and if that water is not well redirected, as I saw in many cases, you will flood the plant room. We all know that the installations, heating or cooling, are provided with air eliminators. And when you eliminate air, that air allows the pressure to drop. Look, in our case, we have 0.5 bars. Because the pressurization unit is set up to start the pumps and to keep the pressure at 0.8 bars, you will run the pumps, which will push water into the system, and it will compensate the air eliminated by the air eliminators. And then, as you will see, the floating valve will allow the water to pour inside the tank on the pressurization unit to keep that tank full. But I really want you to think of something. Normally a pressurization unit have a limitation on how many times it can fill the system, because if you'll have a leak, you do not want to flood the premises, especially if the premises are a kind of server rooms, computer room, etc. When 0.8 bar will be reached, again the pumps will stop and the pressurization unit will only monitor the pressure into the system, just like a sentinel. These pressurization units are used mostly in industrial and commercial environment. I didn't meet them very often in domestic. I did, but not very often. Installation volume calculation, it is very important. You really have to consider system's elasticity, because you do not want a massive variation in pressure. The pressure vessel will have the capability to take some of the water volumes, not to allow the variation of the pressure to exceed the design settings, but this is up to you. If you make a big mistakes, or if you choose too small pressure vessel, or installation is too large or is miscalculated, you'll have a surprise. If you look into these pictures, the rubber bellow inside the pressure vessel will shrink, allowing the quantity of water to go inside, reducing the pressure variation. A badly designed installation based on wishful thinking will lead to all sorts of issues. If you will see here, the pressure exceed 3 bars and the pressurization unit will stop the boiler normally, because the boiler have to be integrated with the pressurization unit. And this has happened because whoever designed the system disconsidered the system's elasticity, or maybe some malfunction, or the system is clogged and boilers overheat. That can lead to all sorts of problems, and one of the bad one, it is putting under pressure the pressure vessel, and the rubber bellow sometimes can be damaged inside. Then you will lose the elasticity completely. And believe me or not, if you'll over exceed 3.5 bars, the pressure relief valve will allow the water to go outside, and if you not direct that water very well, you might flood the premises. So then you will repair, recalculate, reinvest money, and you'll make sure that everything it is okay. I think a good idea it is to do a good calculation in the first place, otherwise it is very demanding work to pull new pipes through the walls, especially when the building is ready. So this is about the pressurization unit, and I would like to speak in next video about the pumps, the cavitation, the pressure required to the pump's intake, and why sometimes the gases are adding up into this radiator that are onto the higher side, how to put the air eliminators, and to have troubleshoot free installations based on genuine science and not in wishful thinking design. To be able to move liquid through an installation, you need a pump, and the pump should have a specific speed. If the pump moves too slow, you will not move the liquid through the system. If it moves too fast, you can have cavitation, all sort of problem. So everything is based on balanced installation. I'll see you on the next video when I'll explain to you about the cavitation, the way the pump's running, and all these things. Thank you for watching my video, and then I'll see you on the next video with more information. Thank you. Bye.